Show you about this topic of enterprise integration patterns today, and of course we can also discuss it after the session if you have any questions or feedback for me. So let's go to the slides, please. Okay, so here we are. So first, usually with my talks, I start with the key takeaways for you. The key takeaway first is that really integration is a key factor for success of business in the future. And that's really not just important if you're working in the area of integration, but everywhere. And that's what you will see in this talk today. And therefore, enterprise integration patterns, which is the key topic of this talk, is very important. And it's important for every developer, no matter what you're working with and what topics you are implementing. And the third part, and you will see this in the second part of the session, is that enterprise integration patterns are very important for many different use cases. And what we are seeing more and more is this kind of real-time integration. I will talk a lot about this later, and because this is really relevant for things like Internet of Things and big data analytics, and you will understand later how enterprise integration patterns and also integration in general is very relevant here. So let's take a look at the agenda for today, 40-minute session. First, a short overview about the motivation. Why are we talking about application integration in general? And then I will give a short overview about enterprise integration patterns, as some of you might not heard it yet before this term. And then the focus of this talk is really talk about how can you use these patterns in practice, using different frameworks and different tools. And not just for the integration projects, as I said, but in the second part I will talk about how to use these patterns in things like big data projects with Internet of Things and all of these real-time big data terms. And at the end I will talk a little bit about the future of enterprise integration patterns. So let's begin first, a short motivation. Why do we have this talk today? And the reason is very simple. I mean, integration is there for all the time when you started programming and many years before probably. Always you had a lot of different applications and interfaces and technologies which have to work together. So you do not have just this application and that application, they have to communicate with each other. And in the last years, you're seeing a lot of new concepts. You're seeing cloud applications. So companies are not just using their own software, but also software in the internet. And you have mobile application. Everybody has a smartphone with him. And you have to combine with that and communicate. And Internet of Things makes it even more important because now not just the people use smartphones, but every internet thing will communicate. So if it's the refrigerator or whatever it will be in the future, in the manufacturing area we see it a lot already, but it's coming also to the smart homes, to everybody's home, the Internet of Things. And so there's a lot of heterogeneity and new paradigms are coming all the time. In the past, probably most of us did not work at the time. We used mainframes and client and server communication a lot. Some of that is already 40 years old, but it's still relevant. So all the banks still use mainframes with COBOL and very old legacy technology. It's not modern, it's not microservices, not real-time often. But that's the thing it is, and it's still relevant. And now we're talking about cloud and big data and Internet of Things. And all these heterogeneous communication styles and programming concepts have to work together. And this is so relevant, and so you have to integrate all of that stuff. And what many did in the past is they first started and using one application and connecting it directly to another one. Like, for example, you had a mainframe and wrote a code which connects this one to a specific ERP system or something else. But that's what we often call, and also our customers call, the point-to-point hell, because it's very complex, as you see on this picture here on the right, and that's not really maintainable and not efficient for the future, where we get so many more applications to integrate, like cloud services, like the Internet of Things. So it's getting more and more important to integrate all these things. And of course, there are a lot of different options how you can do that. There's so many options for application integration. So you can always write this glue code and do the point-to-point connections. That's always working if you have only 2 or 3 simple connections which you have to implement. But in reality, and that's again increasing a lot with big data, with Internet of Things, with software as a service in the cloud, you have to connect many more different applications. And though we do not want to write glue code all the time, it's not possible. We do not have the time for it. It's too complex. And so what do we want? We want patterns, frameworks, and tools for doing this kind of integration. And therefore, we want to use standardized modeling. We want to realize it efficiently. And of course, we also want to test it automatically. We cannot implement all of that by our own with writing the code. And therefore, now we come to the enterprise integration patterns. So this was a little bit the motivation. As you see, we see a lot of integration everywhere, not just in specific integration projects. And now, what's the enterprise integration patterns? First, as there's the term pattern in it, design patterns in general, everybody knows that probably if you're a developer. It's a general solution to a problem in programming. And these design patterns are reusable and they speed up the development. Because you take a look at this problem once in the pattern and you can reuse it all the time. And the same idea, of course, is also here for the enterprise integration patterns. Though here you see in the right a book, Enterprise Integration Patterns. It was written by Gregor Hoppe and Bobby Wolf around, I think now 12 years ago. So it's for IT technology a relatively old book, but nevertheless it's still very relevant. And this book has the goal to define a design guidance to describe and develop robust integration solutions. So here the key really is this book. It's around 600 pages or so, describing a lot of different patterns which you can use for integration problems. So if you have one huge problem, you can make it smaller into small chunks of problems and reuse these integration patterns all the time. And the funny thing is, even if you have never heard this before, as a developer, you definitely have used some of these patterns already. As you will see some examples in the next slides, I'm pretty sure you know a lot about some of these patterns. Not all, there are more complex ones, but the simple ones, you have definitely used some of them, even if you've written just some simple Java code. And these patterns, as I said, the book was created around 12 years ago. Gregor Hoppe, the founder and the creator of these patterns, had a great talk about why he created this book and why he defined these patterns. You can take a look at YouTube. I referred to the link. So it's about 60-minute talk really about the history and why he created the patterns and about the problems he solved that time. It's really a great talk worth watching. But today, the focus is not on the history, but really on today and the future. So I want to give a short overview about these patterns and then really how you can use them in practice today and in the next years. So let's take a look at the first example if you have never seen these patterns before. This is the splitter pattern. And if you see here on the left, we have a new order coming in this case. So it's a typical business case you implement in your projects. You have a new order, and this new order has several order items. So if you think about Java, it's nothing else than a list with different items in this collection. And you have to split it up so that you can process every one of these order items by itself. So compared to Java, again, it's just a list and a for loop, and that's what you code in Java. And here it's defined as the splitter pattern. In this book, you have a lot of text to all of these patterns, which defines many best practices and how you do it and what's the way to implement it and to use it. Though it's more complex than it looks in the first beginning to do it in the right way for the right use case. Another example for such an enterprise integration pattern is the aggregator. It's a little bit the different thing to the splitter, because here you again, on the left side, you have different inventory items, 1, 2, and 3, and you have to aggregate them again to use them in one inventory order. So this is again a typical use case you have to implement in Java or any other language all the time by writing for loops and by adding the business logic and so on. Under the hood, you still use some of these patterns here, like the aggregator. And the huge benefit of all of these patterns, it's around, I think, 60 patterns or so, is typically not just by using one of these patterns, but by combining these patterns. That really shows their true power. And now let's take a look at such an example. Here we have the composed message processor. And this is just really combining them different patterns. On the left side, you have the new order with different items. And then first you use the splitter pattern to split it up into single items, and then you use another pattern which is the content-based router, and the router is also something you probably always have implemented in Java or whatever, and then you decide if the content of this item is this, then send it here, or if it's another content, then somewhere else. So just using simple expressions or whatever you make for use for you doing your decisions, and then you have routed it to somewhere for processing it. And afterwards, you have to use the aggregator, because after you have processed the different items differently, then you have to aggregate it again, because in the end you need one validated order which aggregates all of them. And so this really is a very simple example of how you can combine different enterprise integration patterns. In our real world projects, of course, you combine this a lot more, so if you have much bigger integration problems. And as I said again and again, these integration problems, you have them also in your business cases. It's not just about specific integration projects, but you implement all of that in your business logic too, typically. And why not use some simple patterns instead of a complex project? And so this way it's much easier to implement each chunk of this problem. And so if we take a look at the status quo of these enterprise integration patterns, the good news here is they do not change. The book is 12 years old, but still it doesn't change. The problem is still the same. Sometimes the technologies change. You use, as we heard in the keynote, Java, Closure, JavaScript, or whatever you use for your specific problem, but the patterns do not change, just the technologies. And also the good news is that there is a lot of implementations available for these patterns. As I mentioned before, of course, you can use Java and a collection and a list and iterate through it. That's the low-level part. But there's a lot of frameworks and tools which are a much more powerful solution which you can use for these patterns. And you will see a lot of that later in this talk. So this was a introduction to enterprise integration patterns. Now let's take a look shortly how we can model that. Because one of the strengths of these patterns is that you can use it visually. So you do not discuss it in source code or just by writing it down, but you can use all of these patterns to define the complex problems in chunks of problems. And that's much easier, not just for discussing it with colleagues, but also for documentation, or when you make changes later, it's much easier with this documentation instead of writing it down in text in any language. And therefore, here's again one example, and the benefit is here, even if you're not a technology expert, and if you have to talk to your manager or your project lead, then you can use these kind of documentations much easier to discuss with him the use case you implement. In this case, even if you have never seen the patterns before, you understand what is going on here. Now in this example on the left side you have a file folder where you get your orders in CSV files, and then you use the transform pattern to make transformations to these files, because for example you have to change the XML structure or something like this, and then you use the splitter, in this case the CSV splitter, so you have a file format CSV, comma separated, and you are splitting this up into the single items, and then you use again the content-based router, and depending on your expression you either send it to the CD folder, to the DVD folder, or to the others folder in this example. So as you see, it's very easy to understand, and the benefit also is that you have tooling support for that. So even if you do not want to implement it with any framework, but just use it for visualization, for documentation, for discussions in your project, then you can use plugins for free for your tools. For example, for Windows, we often use Microsoft Visio for modeling, and here you have a free plugin to use these patterns there to make your documentation. And the same for Mac users, you can use OmniGraffle, for example. So there are different plugins available, usually for free, that you can use these patterns for visualization easily. And I would really recommend to try it out to document especially integration problems or some kind of the style with these modeling tools. But the key really is, and now that's the main topic of this part, the next two sections, is that you usually do not just want to visualize it, but you also want to implement it, of course. And as you will see in the next, there's a lot of different open source frameworks and also commercial tools available to do that. So let's take a look at the different options you have when you want to really implement it, but you do not just want to use Java code and write everything by yourself with the glue code, with the Java collections, but if you want to use some higher level frameworks which support you by doing that. And there are three options. There are integration frameworks, as you see on the left, integration products, and what I call integration suites. And I want to introduce all of that to you and also show the differences. So let's begin with the integration framework. The integration framework is, as the name says, it's really a framework. So this is in the end libraries which you add to your project. So if you're coding in Java, this is just some additional jars which you add to your project, and then you can use these frameworks. And these frameworks offer to you a lot of different enterprise integration patterns already implemented. And the benefit of that is that you don't have to write the glue code by yourself, but you just have to use the method or operation which is already implemented for you, like the router, like the splitter. You don't have to write these for loops by yourself again, because these methods are already implemented in these frameworks. Besides that, you have a lot of connectivity implemented. So no matter if you have to integrate files or messaging or web services or Salesforce or any other system, these connectors offer you the implementation under the hood already. So the glue code for all the different technologies is already written for you, and you just have to use them here. And that's a huge benefit of integration frameworks. So in any project, no matter if it's a specific integration project or if you're implementing business logic, if you have to connect to different sources, and if it's not just one or two, then you have a lot of benefit if you use one of these frameworks. They're open source and free, and you can use them. And they are really helping you with the integration of different technologies, as I already told you. And here's just some examples. And again, the benefit is the glue code under the hood is already implemented for you. And there are so many different connectors available depending on the framework you choose, of course. And it's also very easy to create your own component. So that means if you have requirements to implement a technology which is not available in your framework, or if you have some internal data format which you want to integrate, like in a banking company, they have specific data formats only for them internally. Then you can write this component here once for your internal data format, and then you can reuse this component again and again, and combine it and use it like the other ones. And in the end, I know really 3 different integration frameworks on the market which are very widespread. In the Java environment, it's especially Spring integration, so it's part of this Spring framework which probably everybody knows, and it's Apache Camel. For .NET, there's also something available called N-Service Bus, but actually most of them are really for the Java platform. And I would say that Apache Camel is the strongest one and the most important one. It has in my opinion, but it's my personal one, the best features, the best community or the biggest community, and so should be the main focus if you want to use an integration framework in the Java platform. The only difference maybe is if you're really using a lot of the Spring framework already, then Spring integration might be the better choice here. But also Apache Camel has a lot of Spring integration, so maybe you also Google it a little bit for the differences and then make your decision. But in the end, for Java, and as we're on the JavaDay today, the 2 options for using such a framework, open source, for your project is Spring integration and Apache Camel. And now let's take a look at a short code example of that, how this looks like. Here you see what in Camel is called a route. It's an integration route. And you always have some incoming endpoints, so from, and you have some outgoing endpoints, which is called to. So you're getting information from one point and you're sending it to somewhere else. And in the middle you use all of these patterns. And in this case, it's around 10 lines of code. I have used 7 or 8 integration patterns. And as you can see, you always just have to use the methods and operations and call them. And the logic is implemented for you under the hood. So for example, in the middle we have the .split, which is the splitter pattern, which under the hood implements the for loop and all that stuff for you. You just call the split pattern, and then it does for it under the hood for you what you're expecting from this pattern. Or you have the choice method. The choice method is similar to the content-based router in the enterprise patterns book. And this way, with only a little bit of code, you can implement very powerful things. So if you try to implement this logic here, and it's the same from the graphic which I showed you before about the visualization, reading files and then doing transformations and then doing content-based routing, sending it to CD, DVD or others. And that you can implement in 10 lines of code with such a framework like Apache Camel. And also the huge benefit, as you see here, is the connectivity. In this case, in the from, we use the file connector. So here you see from file. So this means you read files from directories. And at the end, in this example, it's a very simple example. I use 2 different connectors. It's also, again, the file to put it to a directory. And I use the mock component. The mock is really like from unit testing that it's just a mock because there's no really output defined yet. And here with Apache Camel, there are around 150 connectors available already for FTP, for web service, for JMS, for anything else you think about. And you can really, if you want to read from a file and then instead of storing it in another file directory, if you want to send it to a JMS queue or call a web service with the transformed and rooted information, then you can just replace this one by JMS and then send it to the JMS queue. And all the glue code under the hood is implemented for you by this framework. And that's really very, very powerful if you have to connect to different technologies. You really should try this out, how much this can help you writing less code if you have to integrate different technologies. Here's another example of Apache Camel. It's the same root, or also a root, but it's implemented in XML. So a framework like Apache Camel offers you different DSLs, different domain-specific languages for doing these roots. So Camel, as far as I know, supports Java, XML, Scala, Groovy, and I think even for Closure it's already a DSL available. So you're very flexible here by choosing your preferred language for doing this. So next, let's take a look at integration products. So integration products, that's in the end usually a commercial thing. So it's not an open source Apache framework or so, but here you usually pay for it. And the difference is from the products, if you take a look, they also have the same benefits as the integration frameworks, connectivity, routing, the patterns implemented and so on. But you also, on top of that, have a lot of different tooling which you can use. You have different monitoring options out of the box. And what's also important for many customers is that you have commercial support. So often these frameworks are used in mission critical systems, and then it helps you a lot, of course, if you have 24/7 mission critical support, depending on the company you work worldwide or wherever you need the support. So that's a little bit the differences. And what's also different in the meantime, and I've used here some reports from analysts like Gartner and Forrester, and what they are seeing, and also what we see at our customers, is that in the past you just used complex enterprise integration products for really big, expensive projects and used by a lot of developers. And in the meantime, Gartner is talking about the citizen integrator, Forrester is talking about hybrid integration. What that means is in the end that we have many different kinds of integration projects and requirements. Often it's not done in the complex integration project in the IT department, but it's done, for example, really by the business user, which wants to do some integration. So really the conclusion today, and that's a little bit different than maybe 2 or 3 years ago, one integration product does not fit all problems in these days anymore. So yes, we have the enterprise service bus. This is really the integration flagship many companies use for doing many complex integration for their mission critical systems under the hood. That is what you typically know about when you talk about integration product, then it's an enterprise service bus. In the meantime, often many vendors offer products for business integration. So that's really about self-service integration, so do it yourself. So that's really when the business users just use a web application and do some simple integration. They don't have technical background or so, but they really just want to integrate from Salesforce to Facebook or something like this. So very, very simple things in the web UI. And what also many vendors in the meantime offer is called cloud integration, or also integration platform as a service. Here it's a little bit in the middle, so it's not for the business users, but that's really for the people which have a little bit of technical background. But nevertheless, they do not want to use a complex IDE where you develop a lot of code, but they really want to still use a web UI where you just drag and drop a little bit and do a little bit more complex integration. So you have different integration approaches in the meantime which you can use for products. If you do not want to use just an open source framework for coding and writing all the code by yourself. So different integration products nevertheless all have the same concepts. You still use the connectors to different technologies and different products. And on the other side, you also have the process design tools. And this is probably the huge difference to the integration frameworks where you write all your code. But here you really have process designers where you develop it graphically. So here a lot of people say to me, hey, Kai, I tried it out 8 years ago or so and it was really horrible and didn't work, and that's really true. So if you have tried it out a long time ago, you should try it out again, because this changed a lot. This kind of tooling of different vendors got much, much better, and today it really can be used in a very good way. And with this, with the connectors and the process design tools, you build your integration processes. And here the key again, the focus today is the integration patterns, and the enterprise integration patterns are part of these process design tools. So while I showed you in Apache Camel, you write the Java code or Scala code and use the operations and methods to implement or use these patterns. Here it's via graphical design. So let's take a short look at the different examples at the enterprise service bus, which is really used often for the complex integration products and projects. And here you have really an IDE, so usually it's based on Eclipse or something like this. And here you do drag and drop and all that stuff, and really code it in the drag and drop solution. iPaaS for the citizen integrator is very similar, but it's in the web. You use just your web browser, and therefore it's not as powerful as the ESB, but it's also easier to use. And then we have the integration for the prosumer, the professional consumer, which is really a business user which just want to connect something like LinkedIn or Facebook or Salesforce or so. Really not very powerful, but it's okay for some simple things which you want to do in your department, right? And you don't need an IT involved into that. And so that was a little bit an overview about different frameworks and tools. So in the end, both is available, open source for free, just if you want to code, or you can use different tools and products, depending on if you want to really do it powerful enterprise integration with a tool like an enterprise service bus, or if you want to use a simple cloud tool for that. And now let's take a look at, well, I just talked about integration with frameworks and products, but what's also important, these kind of enterprise integrations patterns are getting relevant everywhere. And let's discuss a short example here which we're implementing right now today with the Sacramento Kings in the US with NBA team. They are building a new stadium, right? And everything there is connected, and that's how the world is coming everywhere worldwide. And here, if you today go to a game and even if you're not in the stadium but driving there, every street and everything like Google Maps is connected, and your app recommends you the right way to go. Not just looking at traffic jam, but also, for example, if your seat is on the back of the stadium, then it recommends you to drive there. And then while you go to the stadium to your seat, maybe you get a push message that there are VIP seats available in front of you, and so you can do things like cross-selling and correlating all the different information in real time. And here is really the key difference, that all of that has to happen in real time, these location-based services and so on. So it's not just batch processes, but it's also not just web services where you do some database queries and then process it, but it's really processing the data while it is in motion. And that's with these kind of new technologies for streaming analytics and log analytics, operational intelligence. That's the things you use for implementing use cases for Internet of Things. And here it's all of that is in that story. And after you go out of the stadium, when the game is over, there's a lot of different other things connected, so integrated, like other shops, for example, the restaurant and also the hot dog stand where you sell your hot dogs. And after the game, if the game is over, but you still have 1,000 hot dogs to sell, then there's again done a lot of correlation, because you know if you do not sell the hot dogs today, you have to throw them away because you cannot sell them next week. So they are garbage. And though again, it's correlating all the information of the guest, of the hot dog stand and all the other things, and is sending push messages to these people which are walking to this hot dog stand, to his car. Then you get a push message, for example, hey, dear customer, today you get 70% discount for this hot dog, because then you still earn 30% instead of throwing it away, and it also makes the customer happy because he gets it very low priced. And this way you see that everything is connected, and that's so important, and everywhere here you also use this kind of integration patterns. If you think about it from the past, the evolution of integration, in the past we did a lot of ETL batch processes. So for example, processes which run over the night and took a long time. Then we came to enterprise application integration with client-server, messaging middleware. Then since 10 years ago, we are implementing a service-oriented architecture, or at least we are trying to implement it with things like SOAP web services, complex XML, and so on. And in the meantime, we are really talking more about real-time. And we are talking about location-based services, open APIs. We're using things like in-memory computing to do it really in real time, all these correlations, together with mobile communication and cloud communication. Though the evolution of integration is really happening a lot, but still the patterns which we are talking in this talk are not changing. But they are used everywhere, so they are not just used in the enterprise service bus or in the integration framework. And so let's take shortly at a few other examples where we use these patterns. And that's what I call here integration suite. Now that's just showing that it's not just important in the integration frameworks and products, but really everywhere. And let's take a look at some examples here. For example, the streaming analytics, where you really process the data while it is in motion. So you have different sliding windows and have to correlate the information. And that's, for example, happening if customers are going to a store. If they are leaving the store already, then it's too late to do cross-selling because they're already gone and maybe go to another store and not to your store and buy there again. Or if it's about fraud detection, if a fraud has already happened, then it's too late. So you have to process the data in motion and correlate it to act before the fraud happened. Or what we see a lot with streaming analytics is things like predictive analytics, so predictive fault maintenance, for example. We have a customer with an oil platform, and they are correlating all the sensors to predict if a machine probably will explode. And they have a lot of patterns for that and are correlating it in real time to replace some machines if they are gonna explode with a probability of maybe 60% or so. And here, as you see in one example here, this is again one product which is used for streaming analytics. So it's not an enterprise service bus, but really a stream processing product. On the other side, you could use, for example, open source frameworks like Apache Spark or Apache Storm. These are the kind of frameworks which you use for stream processing. And here you see, I use the product again because here you see it better that here again, these components which you use here, these are again just implementations of patterns. So here you can do things like filter, like route, like aggregate, and so on. And that's again under the hood. If you take a look at the book and descriptions of these enterprise patient patterns, you're just using these patterns every time. Of course, it's some other different concepts. Like here, you're not doing a web service request response or a database request response, but here you're using things like sliding windows and continuous queries. But the patterns behind it are usually the same in enterprise integration patterns. Or if you talk about open API, what we see more and more, that you want to publish your APIs not just internally to your company, but to external partners. Then you also have to use patterns. You have to route it, you have to do transformations. So many customers use, for example, SOAP web service under the hood. But if you want to expose it to partners, then you have to use REST services usually in the meantime. Or even some messaging via WebSockets to the mobile phones. And here you have routing and transformation and all of these things. Again, to implement these kind of gateways, you use the patterns, the enterprise integration patterns. Or other things. I mean, I have a lot of examples. For example, for log analytics and operational intelligence, when you're having a lot of different distributed logs and you use a product like, for example, Splunk or TIBCO LogLogic, or open source, it's things like Elasticsearch and Kibana and Logstash, where you really process many different log files. And if you take a look at what you're doing here in the workflow, it's again just using these enterprise integration patterns. You're collecting data, storing it, indexing it, parsing, normalizing, formatting and forwarding it. That's exactly the patterns you have defined in this book with details, with best practices and all the things. So whatever you're doing in your projects, it really helps to understand these patterns. So it's not just about integration. And I've talked about this a lot, even if you're just implementing business logic. For example, today many people do it with microservices, where we really have small services which can be developed, deployed and scaled independently. So no big ear package in a Java application, but each service by itself deployed. Then you can still use these enterprise integration patterns instead of writing glue code for your Java collection, for your iteration and for loop. You can still use these patterns. It makes absolutely sense. So the last thing here, often people wonder then, okay, do I use better one integration suite for all these use cases, or how do I do all the different things I have shown, like enterprise service bus integration or streaming analytics or API management? And I mean, the differences are relatively clear. You can use frameworks or products from different vendors and choose what you want. Often what we see, and what's a problem often, especially in mission critical systems, is that you have to write the glue code by yourself between the different frameworks of the different vendors or whatever you're using. I mean, the benefit here often, of course, is if you use frameworks or products from one single vendor, you usually should have this integration. And what's even more important for the mission critical systems, you have the commercial support. So for example, if you take a look at the open source area, if you take a look at JBoss, what they are doing, they are offering things like support for Apache Camel, but also for other frameworks like Apache CXF for the web services and for BPM and so on. So they have a stack of frameworks which you can use. And if you use all of that what JBoss supports, then you get, of course, support for all of that from one vendor. Or the same for the commercial side, if you use everything from TIBCO, for example, of course, then you get support for all of that. So that's the main difference in the end. So that was here the overview, and now let's take a short look again at enterprise integration patterns. The bad news, it's 12 years or so old. Since then, there's no new release of the book and new patterns. Gregor Hopi planned a lot to write about conversations, comrex, event processing, error handling, and so on. He had a lot of visions for conversations and processing and that stuff. But not really much came there in the last 12 years. The funny thing is, I had the same talk a few months ago in Munich at the OOP, and Gregor was also attending the talk, and afterwards he tweeted that, yeah, thanks for the talk, and new patterns are in the works. So he told me that something is coming soon. But nevertheless, even if there is nothing new since this book, the important thing really is new patterns are often not necessary, because these enterprise integration patterns, they still use concepts which are working today. Often these things are good enough. So for example, in the end, often you do not need patterns for conversations, because conversations mean state. And if you look at modern architectures using RESTful services, using messaging to the mobile phone, usually it is implemented stateless. And because many people say that state is really an anti-pattern for many use cases. And so the good news is these patterns are enough for most use cases. And also the good thing is that the tooling is getting much better here. So no matter if you're using just an open source framework like Apache Camel, or if you're using products from TIBCO, from IBM, from Oracle, they are implementing these enterprise integration patterns in most of their products. So not just for enterprise integration, but also for streaming analytics, for API management, for log analytics, operational intelligence. Everywhere you see these patterns under the hood. And therefore, in the end, the last slide, as I've hopefully shown you, enterprise integration is getting more and more important because you have to integrate something everywhere, no matter if it's business logic, if it's streaming analytics for Internet of Things, or whatever you're implementing. These patterns are really relevant everywhere, and so I can really recommend everybody buy this book if you do not have it already, and take a look at it. It helps you no matter what you want to implement. And so let's get to the key messages again. What did I want to tell you today? Integration is the key factor for success of business in the future, because you need it really everywhere. And the enterprise integration patterns therefore are used everywhere, and it really helps to understand them and know them. And not just the basic ones like splitter and content-based router, but maybe you also take a look at the little bit more powerful ones and how they could help you, because they might not be used by you already. And then real-time integration is the real game changer, especially if you take a look forward at big data and Internet of Things and use cases like fraud detection or predictive maintenance, predictive analytics. Then here you really need real-time integration. You still use these patterns, but not with request response, with web services, with databases, but you use this with other concepts like with sliding windows, with continuous queries. And so some concepts change to adapt to the modern world, but the patterns are still the same. And that's in the end my takeaways for today. And now I think we have a few minutes for questions. If someone has questions, If not, you can also come to me afterwards, or I'm glad to get feedback via Twitter or via email or via Xing, LinkedIn. There's one.
And you said that Gregory is soon will be available new book with patterns. There will be extremely new patterns or just remake older?
He will really create new patterns because the old patterns are still stable, and as I told you in the talk, they are still relevant, and no matter if you use it for old legacy integration or for modern things like streaming analytics, the patterns are the same. These ones, the enterprise integration patterns, so the book is as good as it was 10 years ago, but there will come new patterns for some new concepts. So probably for things like the streaming analytics, for things like continuous queries, where he simply did not define patterns because it was not available 10 years ago. Therefore, you will see new patterns in the next time from him.
Okay, thank you.
Okay, then again, I appreciate every feedback afterwards, and thanks a lot for coming, and have a nice day at JavaDay Kyiv.